Welcome to AP Biology. Today I want to talk about the light-independent reactions, which is the Calvin cycle. So the light-dependent reactions is what we talked about in our last video. And in the light-dependent reactions, water is split. So if you remember the equation for photosynthesis, it requires carbon dioxide and water and light. And so what we're doing in these light-dependent reactions is splitting water. The electrons from that go through an electron transport chain, but first they have to be bumped up to a higher energy level, and that's where the light comes in. So these are the reactants for the light-dependent reactions. And then oxygen is just a waste product from splitting water. So if you look at photosynthesis, it's carbon dioxide, water, and light, which makes glucose and oxygen. So far we haven't dealt with any carbon, right? And we haven't dealt with any carbon or any carbon, whether it's the inorganic type or the organic type. So we haven't made glucose and we haven't used carbon dioxide, but we've used and made everything else. And so with the light-dependent reactions, they require light, right? Light energy is converted into ATP, and the electrons end up on this delivery molecule, NADPH. So now what we're going to talk about is the Calvin cycle, these light-independent reactions. And so in those, carbon dioxide is finally used. So here's the carbon dioxide in the Calvin cycle. The Calvin cycle takes this inorganic carbon, just one carbon, right, and produces organic glucose, so organic molecules. That's called carbon fixation. We'll talk about that. I'll define that for you. So what we're doing here is adding energy, ATP, to change this inorganic molecule to organic molecule. And then the other thing we're doing, see how there's no hydrogens here, but there are hydrogens here. So what we're doing to get from here to here is adding some protons and some electrons. That's what a hydrogen atom actually is, right? And so adding the electrons, that means we're reducing. Reducing. So we're reducing this carbon dioxide to make organic molecules. So let's talk about this Calvin cycle. First of all, where does it take place? It takes place in the stroma. Takes place in the stroma, which is the gel-like material inside the chloroplast, sort of analogous to the maybe the cytoplasm in a bacterium. So I like my highlighter. Okay, so carbon dioxide molecules enter the cycle by joining other organic molecules. So that's right here. So carbon dioxide joins RUBP, which is this molecule. And there's an enzyme called Ribisco that does that. I do not need you to memorize every enzyme, but Ribisco is actually an important one. It's the thing that does carbon fixation. So what is carbon fixation? It's when you change carbon dioxide, inorganic, to organic. So that's something to know. So this enzyme is actually really important, and it evolved really, really early in photosynthesis. So I want you to memorize that one. Every other step, there's a whole bunch of intermediates here. And so you should know that there's a bunch of intermediates, but you do not need to memorize their names. And I also want you to know that there's an enzyme that catalyzes every step, but you do not need to know the names of those enzymes, just Ribisco. So ATP right here, let's move me out of the way. So ATP is needed because carbon dioxide has very little energy. You can breathe all day and you don't even, there's really no energy in carbon dioxide for you to use. So we add energy from ATP, and then the electrons and the protons from the hydrogen atoms of NADPH are used to reduce the carbon dioxide. Remember, carbon dioxide doesn't have hydrogens, but glucose does. So that's called reduction. And then we're going to regenerate the whole thing. So this is a cycle, and you regenerate this RUBP, this molecule that you started with. So it's called the regeneration phase. So The other thing to know is that you don't actually make glucose at the end of this. You make this molecule called G3P, glyceraldehyde 3-phosphate. I wouldn't memorize that, but be familiar with the term because it's the thing that is made in photosynthesis. So you'd actually need 2 of these in order to make glucose because there's only 3 carbons, but glucose has 6 carbons. So how many spins of the Calvin cycle do you need to make G3P? Well, there's 3 carbons here, right? So you'd actually need to have, whoops, so you'd actually need to have 3 carbon dioxides. How many do you need to make glucose? Well, there's 6 carbons in glucose, so you'd actually need 6 carbon dioxides, right? So for net synthesis of 1 G3P, the cycle has to do 3 times, right? But to make glucose, it would have to actually go around 6 times. All right, so the Calvin cycle actually has 3 phases. The first is called carbon fixation, which I mentioned. That's inorganic carbon being added to organic carbon, making this organic carbon. So carbon fixation is the switch from inorganic to organic carbon, and the enzyme that does it is Rubisco. The next step is reduction, adding electrons and protons, actually. The electrons are what we follow for reduction, but we're adding electrons and protons, and you can see that carbon dioxide has no hydrogen atoms. Remember, electrons and protons, right? Guess I'll put a P. Electrons and protons, if you have 1 proton and 1 electron, that's really just a hydrogen atom, right? That's this. And so glucose, remember, has hydrogens, C6H12O6. And so those hydrogens are added with reduction from NADPH. We're also adding energy from ATP, so we're phosphorylating these molecules. And then finally, regeneration of this first guy, RUBP. So I would be familiar with a few terms. Be familiar with the enzyme Rubisco. Be familiar with the thing that's made, G3P, and then be familiar with the molecule that's coming back that you're making again, RUBP. Did I say G3P here? Hopefully I did. So I would be familiar with Rubisco, maybe memorize that one. Be familiar with the sugar that's actually made because it's a half a glucose, and then be familiar with this term RUBP, which is the molecule that Rubisco works with. All right, finally, I want to talk about factors affecting the rate of photosynthesis. This is all the reactants. So the amount of water available. Remember, photosynthesis has carbon dioxide plus water, right? That's this part, plus light, and we make sugar and oxygen. So all of these reactants plus one more thing are going to be the thing that affects photosynthesis. So factors affecting the rate, how fast photosynthesis can happen. If you don't have much water, photosynthesis doesn't happen very quickly. Another thing is the amount of light energy available. If you have more light, you should be having more photosynthesis, unless you have so much light that it's kind of burning the plants. That's not good. Another thing that isn't a reactant is temperature, but it kind of makes sense if you think of the activation energy needed for any reaction to occur. So you have to have enough heat for any reactions to occur. And then finally, amount of carbon dioxide. So AP does like to talk about this one sometimes because they can talk about, they can give you an experiment in which they add both the whole idea of the greenhouse effect, the carbon dioxide, how we have more carbon dioxide in the atmosphere. So that takes into account our ecology unit and puts it together with this photosynthesis unit, this energy unit. So they like to kind of add that in there because AP really wants you to be able to synthesize information from many different units into one. You know, they love to have a question with a lot of different units going into one big FRQ.